So good afternoon, ma'am. I am Marel Bona Ikipanis from BECE 2B. So now I will report question number 1 to 3. Which is a simple beam 50 mm wide by 200 mm deep is 7.5 meter long and has a modulus of elasticity E is equals to 12,411 MPa. The beam has a maximum deflection of 102 mm due to a uniform load over the entire span. So for short, ma'am, ang atong beam is na ay wide nga 50 mm, na ay deep nga 250 mm, ang yang length is 7.5 m, ang elasticity is 12,411 MPa, and ang maximum deflection kay 102 mm. For question number 1, ma'am, the value of uniform load will be I is equals to BD cube over 12. So substitute the value. Kaning mga value, ma'am, kay gipang convert na ni siya. Again, substitute ang B is equals to 0.050 times D nga 0.250 cube over 12. So ang I is equals to 6.510 times 10 raised to negative 5 m raised to the power of 4. As we know, ma'am, nga that the general formula of the maximum deflection will be for uniform loading. So, maximum deflection is equals to 5 WL raised to the power of 4 divided by 384 EI. Muna siya ang atong equation 1. So, substitute the value. W is equals to 0.102 times 384 times 12,411 times 10 raised to the power of 3 times 6. 510 times 10 raised to negative 5 over 5 times length nga 7.54. So, ang atong uniform load diri, ma'am, is 2 kNm. So, our uniform load is 2 kNm or letter C. So, for question number 2, ma'am, for vertical reaction at mid-span, so ang atong missing diri is at ang vertical reaction. As we know that the vertical reaction provided the midspan is for restrict the deflection which is occur in the beam. So to calculate the vertical reaction, we equate the deflection due to the uniform load with vertical reaction deflection. General formula for point load is equals to maximum deflection will be vertical reaction times L cube over 48 EI. So muna ito siyang equation 2. Then, equate na to ang equation 1 na naa sa number 1 og ang kaning equation 2. So, RCL cube over 48 EI 5 WL for over 38 for ay 384 EI cancel EI ang length, and then ang makalculate na nato ang RC is equals to 5 times 2 times 48 times 7.5 over 384. So, ang RC nato is 9.38 kN, but ang naa sa choices kay 9.4, so ang ato siyang i-round off. So, ang atong answer is letter A. So, next, for number 3, by applying equilibrium equation, so summation of moment of A is equals to 0. Negative RV times 7.5 minus RC times 3.75 plus 2 times 7.5 times 7.5 is I over 2 is equals to 0. Then, negative 7.5 RB minus 35.175 plus 56.25 is equals to 0 plus 7.5 RB over plus 21.075. So we can now get the value of our RB, which is 2.81 kN. Next is the summation of vertical forces is equals to 0. RA plus RB plus RC is equals to 15. Wala man tay value sa RA, so atong pangitaon ng RA. RA is equals to 15 minus 2.81 minus 9.38 nga value sa RB o RC. So, ang RA nato is 2.81 kN. Next is the shear force will be at N is equals to 0, RA is equals to 2.81. So shear force at A is equals to 2.81. Next is at just left of C, N is equals to 3.75. So VC left, RA minus 2N. So ang atong VC left is equals to 4.69 kN. Ang VC right is equals to negative 4.69 plus 9.38. So, ang atong VC right is 4.69 kN. At just left of B, N is equals to 7.5. So, VB left is equals to RA plus RC minus 2N. So, VB left is equals to negative 2.81 kN. So, for BM at N is equals to 0, M11 is equals to 0, so MA is equals to 0. At N is equals to 3.75, M11 is equals to RA raised to N minus 2 times N squared over 2. So MC will be is equals to 2.81 times 3.75 minus 3.75 squared. So the value for our MC will be negative 3.525 kNm. Putting MC is equals to 0, so 2.81 N is equals to N raised to the power of 4. N will be 2.81 at where BM is 0. So at N is equals to 7.5. So our M22 will be RAN plus RI. N minus 3.75 minus 2N squared over 2. MB will be 2.81 times 7.5 plus 9.38 times 3.75 minus 7.5 squared. So our MB will be 0 kNm. Symmetrical BM will be 0 at N is equals to 2.81 from right support as well as left support. We know that the maximum BM or the positive BM in loading will be of parabola in nature will be BM max is equals to WL squared over 8. L will be 2.81, W will be 2 kN per M. So we will equate this. So 2 times 2.81 squared divided by equals to 1.97 kNm. So we will convert this times 1,000. So the answer will be 1970 Nm. Nearly gives the maximum bending moment in the beam is 1980 Nm.